good science, what is bad science, what is non-science. For instance, in the other class, one of the students reminded me that a politician was saying that girls should get the HPV immunization because it keeps the women from getting cervical cancer. The HPV virus is implicated in cervical cancer. Now, the politician said the boys don't have to get it because they don't get HPV and they don't get cervical cancer. Well, boys don't get cervical cancer, but boys do get HPV, and that's how girls get it in most cases. But politician is a politician. And politicians are not exactly doing things right. Once we mix politics with science, we get junk, and we get a lot of lies. And that's true for the left, and that's true for the right. Both sides have been pretty bad about it. At any rate, science is a branch of philosophy. It is empirical. It requires us to generate hypotheses and to test the hypotheses and to be able to test the hypotheses. The hypothesis that is not testable is nothing. Theory is a hypothesis that has been tested multiple times and has not been found to be false. We reject or do not reject hypotheses. We do not prove. Or, a lot of people say you prove, but I think that I don't know the word because that's really either mathematical or philosophical, logical. So science can do a lot of things. There are a lot of things science can't do and shouldn't be asked to do. If you can't detect the phenomena that you're working with, you don't have science. For instance, do ghosts exist? Well, Ghostbusters show that they do, but you know, that's Hollywood. Can we detect them? Maybe. We have a lot of stories. I've got a couple of good stories about ghosts, but they're not scientific, and they're not retestable. Okay, so that's enough about science. Science is crucial because your lives are going to depend on decisions made by people who either think science is good or bad or indifferent. Science is a tool. It is not a religion. It shouldn't be a religion. It should not be the one thing that drives every decision in the world. But it's a tool that helps us. Should we put snow tires on our cars this weekend? We can ask an astrologer, or we can ask a meteorologist. Your choice. Meteorologist says it's going to snow next week, by the way. I haven't checked my astrologer lately, but we ought to do that. Make sure the meteorologist gets it right. Anthropology. What is anthropology? Anthropology is the study of humans. It is the study of humans holistically. We like to study humans as not only cultural and behavioral beings, but also biological beings. We like to visit the past. We like to visit what the future might be, but that's a little more hypothetical, so to speak. We have cultural anthropology that studies the behavior patterns and the things we learn as part of a social group. The biological, which is this course, dealing with the biology of humans, our past. We've dealt with the past thus far. We're going to deal with modern things for the rest of the course. How we got to be modern and what we do as moderns. Archaeology, which is cultural anthropology, looking back on past cultures, looking at evidence from past cultures, and sometimes not so past cultures, pretty recent cultures. For instance, thinking of pioneer settlements in Utah or colonial settlements in New York, etc. mass linguistics, which may or may not be part of anthropology. It's not, well, it is, once again, part of our department. We have a really brilliant linguist who is now a full member of our department, Dr. Falva. And linguistics, of course, is studying how languages work, not learning a language, but how languages work, where they came from, how they're related, and how languages work in terms of the sounds and the grammar, etc. We went into evolution. Evolution is an idea that popped up as part of the scientific revolution beginning in the 1500s, and while evolution really wasn't part of that early push. Evolution really only began to be viewed in the last years of the 1700s, that is the 18th century. Oddball wackos like Erasmus Darwin, Charles Darwin's grandfather, had that idea. And slowly but surely, we began to see that this idea of evolution probably worked within a scientific framework. We needed two kinds of evidence. First of all, we needed enough time for evolution to work. Your evolutions change through time. That's my definition. You can have your own. That's my quick and dirty three-word definition. Change through time. So we need time. We can't do it in 6,000 years. Bishop Ussher's pronouncement that the world was created on, I forget the exact hour, 29th of October, 4004 BC. How he got that exact date, I'm really not sure either, but I guess you have to trust him. We need more time than that for all the changes that we saw. And it was Hutton who first, that farmer, who first saw the erosion patterns in the rocks, and was thinking, how many years does it take to put those erosion patterns together, and then lift the rock up and look at that? And all you have to do is run up the canyons here in Utah. In 30 minutes, you can see the work of all of these layers tilted up. How much time does it take to put the layers down and get them up into that position? And how much force does it take? It takes more than those scout leaders pushing the rock off of it. Brilliant, brilliant. Anyway, and now the world is safer for boys. So, time. And then Charles Lyell looks at geology and sees there's a lot of time as well, and shows how we can view the fact that there is a lot of time. Finally, in the 20th century, we get actual means to test how old things really are.